So today we're going to be looking at this circuit here and debugging it. There are four elements of the process: the circuit itself, the breadboard, a detector circuit, and the power supply. So with the power supply plugged in, we now see 5 volts across the terminals. 4.9 actually, but close enough for this. Next up we have the little detector circuit. This will enable us to see when the relay switch goes on, even momentarily, because you'll get a buzz, as here. The most complicated bit is obviously the breadboard, where we see 3 BC547s, here, here and here, 2 capacitors, and a little network of resistors in line with the diagram, a relay with a diode across the coil terminals. Here we can see R1 leaping across from the positive rail at row 4 to the positive side of C1, also on row 4, but the other side of the Great Divide. That's a 10K resistor. Connecting to the common of T1, we have a 1K resistor going to the base of T2 on row 9. Also connected to the base of T2 we have a 2.2K resistor leaping over to the positive rail, also on row 9. That takes care of all the basic components. So now all that remains is to hook up the various missing connections with jumper leads. The first of these is to link the negative end of C1 to the base of T1. The second jumper, the green one in the picture, goes from the emitter of T1 to the negative rail. The third jumper, the red one, takes the common of T2 to the positive rail. The fourth jumper, the yellow one in the picture, takes the negative of C2 to the base of T3. Then the fourth jumper, the orange one in the picture, takes the common of T3 to the negative side of the coil of the relay. Then the final jumper, the red one, takes the positive side of the relay coil and its associated diode to the positive rail. Finally, the long blue and orange wires connect the normally open side of the relay contacts to the buzzer circuit. Well, we'd better check that the relay works, so I've connected the negative rail to the power supply, and I have moved the orange jumper across from the negative side of the relay coil directly to the positive rail, and I'm now going to connect the positive rail. No. Oops, connection's round the wrong way. Anyway, trying again. So the relay plainly works and the buzzer circuit plainly works as soon as the relay coil is activated. So far so good. I've now replaced the orange jumper back to the common of T3, and we should be ready for proper testing. The circuit as designed calls for 100 microfarad capacitors, which I'm going to replace in the circuit where C1 and C2 were until just now. I think I forgot to mention in my opening remarks the 1 meg resistors, taking the base of T1 and T3 to the negative rail. You can see those here clearly on row 2 and row 16. I've left off an important connection, which is a jumper between the positive of C2 and the emitter of T2. So I'm going to put that in place. That is now the blue jumper in the picture. Well, retracing the circuit to check all the connections reveals yet another missing jumper. So I've now connected the emitter of T3 to the negative rail with another green jumper here. That should do it. Well, I've now checked and double-checked all the connections against the circuit diagram, and everything is now in place. So this is the smoke test, connecting the positive rail. Let's see what happens with the buzzer. Oh, beeped immediately. So far from waiting for a few seconds, the relay coil there, do you hear that click? Clicked off, or something, and again, and again. But each of the last 3 clicks did not result in any buzzing from the buzzer circuit, which suggests to me that nothing is really connecting properly in the relay. But as we know, the relay works. I found it a slight convenience to connect a couple of additional jumpers at the back of the circuit for the purposes of short-circuiting the capacitors to discharge them. I know I should probably do that through a 1K resistor or something, but what the heck. Let's try it again. Okay, poised for a retest. Bleep from the buzzer as soon as I connected the positive rail. Click. Click. Big click. Another click. Vibrating noise. That should be the end of it. But whichever way you look at it, the circuit is not performing to specifications, which are that it should create a delay of about 4 seconds. The relay coil should then activate, creating a brief connection of 1 to 2 seconds. Then the circuit should become inactive again. This is definitely not happening. So I'm going to see what happens if we vary the capacitor values, and I've replaced the 100 microfarad capacitors with a pair of 47 microfarad ones. Here we go. Click. Click off. But no buzzer. So pretty quick sequence. Possibly another click, I'm not sure. Okay, so we've been down the capacitance scale to 47 microfarads. We're now going up from the standard 100 to 150s. I've discharged both capacitors, and we're about to connect up the live rail again. Bleep from the buzzer circuit. click, buzz, buzz, clicking, that's probably it. Whatever the case is, it's not doing what it's supposed to. So we'll try again, this time with C1 as a 47 and C2 as 150. Big buzz, on connection, click, lots of clicks, but no real buzzing. And swapping those two around, let's do it again. Click, but no buzz. Another click, but no buzz. On about the right time scale, but the connections just don't seem to be being made properly.